Okay, guys, this is one of the examples that I cooked up on using some text mining features and doing some text mining in R. From the pre-workshop questionnaire that we sent around, I did get one question that asked if I could put together some illustrations of dealing with text-heavy data, such as you might find in digital media or magazine articles or newspaper articles. In this case, I'm going to deal with some PDF files, and I've got this project that I put together that has several examples. In this video, I'm going to go through one of the exercises that I put together on text mining. And so for starters, let me show you where you guys can get the resources for this exercise, the code for everything that I'm going to do here. It's in a GitHub repository. And as we have talked about in this course, if you go out to GitHub, there's a couple different options for you to download the files for this particular exercise. I have a couple different text mining exercises in here, and so the one that I'm going to be going through today is text mining with Supreme Court opinions, and there is an RMD document, an R Markdown document, that I'll be using, and there's also a functions file that goes along with it. So you can go to this repository and you can drop all the code into a zip file and then save it to a local directory for use. You can go individually and get these resources. So you could get this RMD file and you could get this .r script. Just make sure that you're also grabbing the things that are in data because there are a collection of PDF files that I'm going to be working with. Okay, so go to GitHub and dealer's choice, however you want to get these, drop them into a zip file, clone the repository inside of your RStudio console, or just point and click one by one and grab these things. Okay. That's the first thing, and then the second thing is I want to show you what we're aiming towards. So I want to show you what this entire illustration is going to be building towards, and what I'm going to demonstrate here is just making a term count for all of the words that are contained in the majority or dissenting opinions written by Chief Justice John Roberts in the 2019 Supreme Court session. Okay, so this is crazy simple, possibly to the point of being uninteresting, but I think it makes for a nice illustration, mainly because where I'm coming from here is you guys that deal with text-heavy data are the real domain experts in this field. You guys are the ones who know what the interesting things are that you can do with text data and the interesting methods that you can apply. You don't need or want me to tell you how to do a text mining illustration. You don't need me to tell you what methods to use. But one place where I might be able to add some value is just in demonstrating how you can use R to prepare the data for some interesting text-based analysis. And so that's what I'm going to try to do in this video. And I just want to call your attention to this ggplot object here, because this is what the whole thing is going to be building towards, plotting the most used terms by Chief Justice John Roberts in majority and dissenting opinions that he wrote during the 2019 session. Okay, first thing I'm going to do is take a quick look at the source data. And the source data for this example is coming from the supremecourt.gov site. If we come over here to the supremecourt.gov site, there's a page for opinions and slip opinions. And all I want to show you guys at this point is that scrolling down for the opinions of the court for the 2019 session, we have all the cases that came before the court and the opinions for those cases available in PDF formats. So I'll talk a little bit later on in the video about kind of the algorithm used to mine the text from these PDF files, but I just want you at this point to just recognize that the source data is coming in the form of PDF files. And moving back over here, the key R functionalities that I want to draw your attention to for this example are the PDF underscore text method, which comes from the PDF tools package. And that's a method that you can use to read text-based data into an R workspace from PDF files. So we're going to be using PDF underscore text. And then in this particular example, I'm going to be using the tidy text package. And one of the functions there that is going to do a lot of the heavy lifting later on is unnest underscore tokens from the tidy text package. I have another example that I've provided for you guys where I've used the TM package. That's the text mining package, TM. But in this example, I'm going to use the tidy text package. Here I have a little schematic for you guys, which is not perfect, but I think it gives you a reasonable introduction to what I'm trying to do, and I think it gives you a good introduction to what's going to happen when I start moving over to the RStudio console and I start running some code. And so what this schematic is displaying is the workflow that I've set up to deal with this text that's contained in these PDF files from these Supreme Court opinions. And I want to walk you through the schematic here for doing this for a single Supreme Court opinion, so a single one of these PDF documents. And then I think once we've kind of digested the process for doing this for a single PDF document, it'll be kind of clear how we could generalize that to do it for many of these documents. And so the first step is the data download step, and that's where we're just going to jump out to that supremecourt.gov site that I showed you a little bit earlier, and we're just going to click on those PDF files for the cases, and we're going to download those opinions to a directory. I've taken those PDFs and I've dropped about 10 of them into a data directory, a directory that I've labeled data that lives inside of my RStudio project. And then once the data is downloaded, there's a data import step, and this is where we're going to read the text from one of those PDF files into the workspace. So this is where we're going to rely on the PDF underscore text method to take all of the text that's contained in one of these PDF files that is a Supreme Court opinion and read all of that text into the workspace so that we can start working with it as data. After the data has been imported, I have a step that I call get markers, and what this does is it searches through the text for some string literals that kind of give away the positions of the text that I'm interested in. So to be a little bit more specific, I'm going to try to harvest the text for the majority opinion on each of these cases and any of the dissenting opinions that were written in this PDF document. And so I'm going to use a method called str underscore detect. This is from the tidy text package. And actually, I believe it's from the, I believe this method is from the string R package, the stringer package. And it's going to detect a text string that I give it. So there are some unique kind of identifying phrases in these PDF documents that give away the position of where the majority and the dissenting opinions are in the document. And I'm going to use those to create kind of a lookup table of where the majority opinion and the dissenting opinions are for each of these cases. Okay. After I have those markers, I'm going to move on to a step which actually brings in the text that I'm interested in and then parses it out and tries to make it usable. And so the main methods that we're going to use in this step are gsub and unnest underscore tokens. And this is just the step where the markers are going to identify the pages where the majority and the dissenting opinions are in the document. The parse text step is going to go to those pages. It's going to filter the PDF text that we read into the workspace. It's going to filter that for these pages, and then it's going to work with those text strings to kind of clean them up a little bit. And then the final step is that I'm going to organize all this as a data frame so that we can do the word counts. Well, the first step in our process here is that we're just going to get the raw data, okay? And the way that we're going to do that is to go back out here to this supremecourt.gov site that I showed you guys earlier that has the slip opinions for 2019, okay? I'm going to click on one of these cases, right? And you can just download this PDF right into your project. So I have an RStudio project set up that this example lives in. It's a text mining vignette, and I've created a data directory inside that RStudio project. And I can just drop this PDF file right into that data directory. And I've already done this, so I'm not going to do it again, but that's fairly straightforward. And the next thing we're going to do is just take a quick look at this and familiarize ourselves with kind of how these documents are laid out. These are pretty neat. They're like highly stylized documents, and they all look pretty similar. They have a syllabus in the front that has some summary information about the case, and then directly following the syllabus is the majority opinion. And what is pretty neat about this is that the text that designates the majority opinion is unique. You don't see this anywhere else in the document. In this case, Neil Gorsuch delivered the majority opinion, and we have the phrase Neil Gorsuch, Justice Gorsuch delivered the opinion of the court, and that specific phrase only appears one time in this document. And so since that phrase only appears one time, that's really useful, and we're going to be able to exploit that to do this repetitively by using a regular expression search to find where the majority opinion is for these cases. And then after the majority opinion, in this case, I happen to know that this majority opinion runs until about page 42, so I'm going to see, let's see, 42, oh, well, that's not a great way to do that, but if we scroll down to page 42, we'll see that the next thing after the majority opinion in this case is the first dissenting opinion written by Chief Justice John Roberts, and these dissenting opinions can be identified by this header text that is also fairly unique. In this case, at the top of each page of the dissenting opinion, you're going to find this header text that says Roberts CJ dissenting, and following Chief Justice John Roberts' dissenting opinion, in this case, Justice Thomas filed his own dissent. And so this case is going to have one majority opinion and two dissenting opinions. And the text that surrounds those majority and dissenting opinions is going to be something that we can exploit in order to find the text associated with those opinions and save them inside of our R code. But for now, just focus in this part on just downloading the source data and saving it in a directory so that we can bring it into R in the next step. Step one, we just walked through downloading these PDF files. We walked through the act of downloading one of these PDF files that contained a case from the 2019 session of the Supreme Court from the supremecourt.gov website. This step two, we're going to take that text from that PDF file and we're going to bring it into the R workspace. So I'm going to show you guys how to do that real quick. And just as a reminder, this was the court case that we were looking at, the PDF file with the opinion, the majority and the dissenting opinions of the court for this particular case. And we had downloaded that, saved it inside the data directory in our RStudio project. And this is that file right here. So in RStudio, I'm inside the project. If I navigate to the data directory, I can see that file. And the package that I'm going to use here is the PDF tools package. So I'm going to make sure that that's loaded. And the method or the function that I'm using is called PDF underscore text. And it works a lot like read.csv. You pass it a file path. And you have to enter the file correctly, but if you do, you get a character vector. We see that test is an object. It's a character vector with 86 elements. And this has 86 elements because there are 86 pages on this document. So each page of the document becomes an element in the character vector. And to show you what that looks like, let me show you the first element corresponding to the first page of this object. It's a big blob of text, right? So just to really drive this home, length test 1, so the first page, that has that object test, the first element in the character vector test has length 1. So all of this text here from the first page of the document is saved as a single text string, and there are 86 of these strings. So there are 86 big blobs of text which contain all the text on each of the pages. And so that's what this guy looks like. And in the next steps, I'm going to show you guys how to parse this text out a little bit and make it a little bit more usable.